In this tutorial, I'll show you how to set up a forming simulation using Abaqus Explicit. You can use the written tutorial guide to help you through the process. I'll assume that you've already created the CAD for your model and you're going to import it into Abaqus. So let's first import the part. Here's the folder and there's my CAD. And you'll notice it's been saved in a step format, so that's what you need in order to import it into Abaqus. So go to Abaqus, import part, navigate to the right folder which I've just shown you, and then let's import the bottom part in first. Right, you've got to take care when you import the CAD that it's orientated in the right direction. Otherwise you'll have to orientate it once you've introduced it into Abaqus, and you've got to make sure that the units are correct, and we want everything in meters, and actually this CAD that I'm about to import is in millimeters. That's easy to change when we import it. So let's have a go at importing it. Here we go. So we're going to combine everything into a single part. Click on part attributes and I'm going to import it as a discrete rigid tool, and let's go to the scale, and we want to scale it by multiplying all the lengths by 0.001. So, and it'll give you this error message sometimes, or rather it's a warning message, but we're just going to dismiss it. Now we can start removing all the faces from this part that we don't actually need. You can see how I'm going to do that. You click this button here, which is the remove faces button from the tooling. So we just want the face that's going to form the engineering fabric or the composite. Click on that and then start selecting the faces that we don't want. There we go, remove those. Yeah. Now we've moved all those unwanted faces, we can add a reference point to this rigid body tool. So we go to Tools, Reference Point, and then we choose a node, and we'll choose this node here right at the center. And you can see there it says RP for reference point. So we've now imported the bottom part, otherwise known as the die or the female tool, and now we'll do the exact same thing for the top tool, otherwise known as the punch or the male part. Both the tooling parts have now been imported. It's a good idea to save your work occasionally. To do that, you can go up here, File, Save As, and then I'm going to call this Full Scale. You've got to choose the folder that you want to save it in. This is a CAE model, a computer-aided engineering model. Let's see how we can measure the basic dimensions of this part. To do that, click on Query Information, and then click on Distance. Down here it will ask you a question. It's asking you to select the first entity for the distance calculation. So we'll find the distance between this node and the second entity is another node over here. We can see the results of this measurement down here. This is the distance and these are the components of that distance. The length of the Z component from here to here, so the width is 158 millimeters or 0.158 meters. We can do the same thing in the length direction. Query the information, choose distance, choose this node and another node down here. And we can see the distance is 400 millimeters or 0.4 meters. The reason I made those measurements is because I wanted to create a blank holder. We'll position the blank holder so that it's 30 millimeters away from the perimeter of the tooling. And you'll see why I've done that later on when we produce the forming simulations. I'll now show you how to create a new part. So double click on parts, name the part, we'll call it blank holder. Choose 3D modeling space, discrete rigid, shell and planar, and we'll choose an approximate size of 1 and then press continue. You can look at the tutorials provided by the Abaqus documentation on how to create parts. I'm going to make a very simple part. Now we've created the blank holder, I just need to add a reference point. So that's all the rigid body tooling. All we need now is a blank to form. At this stage we'll just create a homogeneous, isotropic, elastic blank. Make sure you choose a deformable part on this occasion. Now we've made all the different parts, we need to mesh them all. To do that, change from the part module to the mesh module, and we'll start by meshing blank. So we go to seed, part, let's change the default size to be a little bit smaller. Keep everything else the same. Check the mesh controls, we are okay to accept quad dominated. Element type, we need to choose explicit, shell, and we'll choose the S for R elements, that's fine. And then finally we just need to mesh the part. Is it okay to mesh the part? Yes. So that's our blank mesh. Because this is a deformable part, it means we didn't have to add a reference point. Now let's mesh the other parts. This time we'll choose a much smaller element size, 0.2. Okay. Again, it's going to be an explicit, discrete, rigid element. So this is a R3D4 element. And that's the mesh for the blank holder. Now just do the same thing for the punch and the die. In the next tutorial, we'll create instances of each part, and we'll position and orientate each instance.